Hi, everyone. All right, so this is starting Unit 9. So 9A is just going to be about solving quadratics by graphing. So a lot of 9A is really similar to the quadratics that we've already done in Unit A. It's really just kind of expanding on what we've already done and just emphasizing certain parts more than others. So this first and second page are really just kind of a review. A lot of 9A actually centers around the last page. So I'm going to kind of breeze through these first two pages just because it's really just a review. If you want more of an in-depth explanation of what I'm about to go through on these first two pages, then I would recommend you go back to 8A and actually rewatch that video. All right, so just getting started. So if you can recall, the quadratic functions refer to equations in the form of ax squared plus bx plus c. So this is your quadratic standard form. And your graphs that it produces are going to be called parabolas. All right, so your parent function is just y equals x squared. And if I expand it into standard form, then you have y equals 1x squared plus 0x plus 0. And then you have your basic standard form right below. All right, so once again, the graph name is called a parabola. Just know your parabola could face up, it could face down, it could be narrow, it could be wide, it could be translated up, left, right, down, whichever way combination. Your domain for the parabolas that we're dealing with in Algebra 1 at least, always will have a domain of all real numbers. Your range, however, in this case, when we're dealing with the parent function, it's just going to be y greater than or equal to 0, or all real numbers greater than or equal to 0. You could see the domain and range written out in terms of mathematical notation, so using inequalities, or you could even see it written out in terms of letters and words and English and all that fun jazz. So just kind of a quick review of that part. So we have our parent function graphed over here to the right, if my face is out of the way. This is just your run-of-the-mill standard parent function parabola. Okay, so this is really just our starting point for all of the parabolas that we're dealing with. All right, so just some really imperative vocab here. So the vertex is the highest or the lowest point of the parabola. The axis of symmetry, or AOS abbreviated, is the vertical and dashed line that passes, hello, I just threw my Apple Pencil. All right, so emphasis on the fact that the AOS is vertical and dashed. All right, so that is your x equals equation that you're going to see. So your parabolas are going to have either a minimum or a maximum, and it's going to be either the lowest or the highest point. So if it's a minimum, you have the lowest point. So a minimum on your graph is going to meet at the bottom, whereas a maximum is going to meet towards the top. So you're either going to have a lowest point, which is a minimum, or a highest point, which is a maximum. All right, and then your solutions of a quadratic function is where the parabola crosses the x-axis. I apparently forgot to write that in. All right, so your quadratic functions can have up to a maximum of 2 solutions. Keep in mind, you could have 0 solutions, which is no real solution. You could have 1 solution, or you could have 2 solutions. Okay, so those are the only types of combinations that we can have. Just remember, whenever you have 0 solutions, like no real solution, keep in mind you must write the word real. Because keep in mind, we can have what we call imaginary solutions. So you have to write the real in that problem. All right, so your solutions to these quadratic equations are going to be written as either a coordinate or as x equals. It doesn't matter, they're interchangeable. Just know on any assessment that we could really give you either or. So keep that in mind. One thing to keep in mind, if I give you coordinates, make sure you're writing down an x-intercept and not a y-intercept. So make sure you're putting the number, then 0. Because if you put 0, then the number, that's actually a y-intercept. So be very careful on that when you're writing it down and when you're on a multiple choice assessment. Because keep in mind, if we're asking for an x-intercept, a y-intercept may also be an option. All right, so another name for a solution, so where it crosses the x-axis, remember. So you could see a word called roots, zeros, or just standard old x-intercepts. So all of these really mean the same thing when it comes to quadratics. It's really just identifying where the parabola is going to have a solution, where it crosses the x-axis, or what have you. It's all the same. All right, and then we have our standard ABC values. So for number 1, we're going to have an A value of 1, B value of 8, and a C value of -3. So we're just looking at the coefficients in the front. So just remember, we only care about the numbers in the front. We're not actually writing the x squared, or the x. We're only interested in the numbers. The x and the x squared just help us figure out which number corresponds to what value. So your a value always corresponds to your x squared, whereas your b value always corresponds to your x value. And then the number that's written by itself, that's always your c value. So if I really wanted to, I could even write it out of order and give you like -3 plus x squared plus 8x. And the ABC values are still the exact same. We still have a C value of -3, an A value of 1, and a B value of 8. It's just written out of order. Okay. All right, and then we're going to skip down to number 3 and number 4. So just know that whenever you're missing a term, you have to pay attention to which term exactly is missing. Just because we only have 2 terms, it doesn't necessarily mean your C value is 0, although it could. So in this case, for number 3, we don't have an x value, which means our b value in this case is going to be 0. Whereas for number 4, we have an a and a b value since we have our x squared and our x, which means we're actually missing our c value. So our c value in this case is going to be 0. All right, so now kind of transitioning into finding the attributes and graphing these parabolas. So for today's lesson here, we're really emphasizing solving quadratics, but we're going to be solving them by graphing specifically. So remember, wherever a parabola crosses the x-axis, that's where our solution is. So that's really the part that we're going to focus on for this lesson. So starting off, we're going to find our a, b, and c values. So here we have an a value of 1, a b value of -6, and a c value of +5. All right, so my calculator just in case. So I'm going to start off by finding my AOS, the axis of symmetry. So your formula for the axis of symmetry is going to be x equals the opposite of b all over 2a. So I want the opposite of b. So the opposite of b is going to be -6 all over 2 times 1. So a negative times a negative in the numerator is going to give us a positive. So we have a +6 all over 2, which simplifies to 3. So your vertical dashed line here, your AOS, is going to be at 3. All right, so I'm going to go ahead and plot that AOS. All right, so there's our axis of symmetry. So now we need to go ahead and find the vertex. All right, so for the vertex, what I'm going to do is I want to take that x value that I just found, and I want to plug it in to my equation up here and see what y value it yields. All right, so I'm plugging in that 3 that I just found. All right, so I'm going to have 3 squared minus 6 times 3, and then plus 5 at the very end. All right, so we're going to have 3 squared, which gives you 9, minus 6 times 3, which gives you 18, then plus 5 here. All right, so then we have 9 minus 18, which is -9. -9 plus 5 is going to give you a -4. So what this implies is we just found the y value of our vertex. All right, so we know it's going to be something common -4. Now the x value is from our AOS over here. That's terrible arrow. Close enough. So that x equals 3, that's your x value. So we know we're going to have a vertex of 3, -4. All right, so I'm going to go plot that point. So here's our vertex. All right, so now I want to determine if it's going to be a minimum or a maximum. So just remember, if it faces up, that means it meets at the bottom, which means we have a minimum. And if it faces down and meets at the top, that means we have a maximum. So another way to look at it, if we don't have the graph, is you can look at the a value. So your a value, in this case, is +1. So because A is +1, that's going to imply that it's going to face up, which means we are going to have a minimum. Why is that gray? That works too. All right. So now for your domain is always going to be all real numbers for the parabolas that we're dealing with. That's terrible. We can do better than that. There we go. All right, and then your range is always dependent on your y value of your vertex. So keep in mind, because we have a minimum, that means we want everything that is going to be greater than or equal to. Whereas if it was a maximum, we'd want everything less than or equal to. All right, so for my range down here, so I know it's going to be y less than or equal to, nope, greater than or equal to. Did I write that wrong? No. Greater than or equal to the y value of the vertex, which is -4. So there's your range. So if you need kind of a visual, we're taking the y value of that vertex, and that's what's being written for the range. So keep in mind, when you find the AOS in the vertex, you've actually found a majority of their other attributes. You just kind of have to plug it in. All right, now for your solutions, this is where you could use the table in your Casio or your TI or whichever calculator you're using. So for the solutions, I would say make a horizontal table or a vertical table, it doesn't really matter. I just say horizontal for the amount of room that you have. All right, so we're doing your X's and Y's. So keep in mind, your first coordinate in your table should always be the vertex. So I'm going to start with 3, -4. So that's my vertex. So the values you want to find next are the X values that come after the vertex. So after 3, we have 4, 5, 6, and 7. All right, so I'll do this using both calculators. So if you have a TI, then that means you need to press y equals. Then you want to plug in your function. So if you have a function, then you want to press x squared minus 6x plus 5. So once you have that in y equals, then you want to press second y equals, and that will take you to the table. And then you can just scroll and find those corresponding values. All right, so we want 4, 5, 6, and 7. So let me get my Casio, got to do those steps. All right, so on the Casio, it's kind of a similar situation. You want to press menu, and then to be able to get the table, you want function number 7. So we're going to the table. Press enter or execute. All right, so if you have anything in your Casio, then you want to press F2 to delete, and then F1 to confirm so that you can clear it. And then you want to type in your function. So we're going to have x squared minus 6x plus 5 plus 5. So once you get this function in your calculator, then you want to press execute so that your menu changes. All right, and then we want to go to the table, which is F6 right here. So once you press F6, then your table is going to pop up. So keep in mind your table value, you may need to reset it. So you may need to press F5. So your table value may start at 1 and go to 5. That's usually typically the default. So if you want to change it and go from, say, another value to another value, this is the default, 1 to 5. You probably are going to want to change it to go from, say, I would say -10 to +10 is a good starting point. So just set it from -10 to +10 with a step of 1. Then press exit, and then go back to F6, which takes you back to the table, and then it starts back at -10. All right, so then you can go back and you can look for those specific table values. So there's where it starts at 4. So then you can just type in those numbers or write in those numbers for your table. So whether you're using a Casio or TI, it doesn't matter which calculator you're using, you should be able to get the table values regardless. And I turned off both my calculators without even getting the values. All right, so for 4, it's at -3. And then for 5, it's at 0. For 6, it's at 5. And for 7, we are at 12. Now keep in mind, our graphs here are a 10 by 10, which means 7, 12 is not going to be graphable on our grid. So I just highlight it in red just so you guys can see it's a table value that we have, but we can't actually graph it. All right, so I'm going to go plot those points. So 4, -3. All right, and then we have 5, 0, and then 6, 5. All right, so I have the right side of the parabola, so now I want to flip it over the AOS so I can get the other side. So I'll kind of show you. So this is from the AOS, we have 1 square to the right, so I want to go 1 square to the left. And similarly up here, we are 2 squares to the right, so I want to go 2 squares to the left. And then similarly up here, 3 squares to the right, so now I want to go 3 squares to the left. All right, so you kind of have those stepping stones for you right there, a little bit of structure. All right, so once you have those points, I would recommend deleting those lines, or actually delete those lines, not a recommendation. All right, so now I'm ready to actually draw the parabola. So please remember your parabola needs to pass through all your points, whether you freehand it or whether you use the, oh my God. Whether you freehand it or whether you use the automated parabola on Notability. I know some of you are doing this on paper. Oh my God, that is terrible. Wow, that is still terrible. Can we not spend 20 minutes on, there we go. All right, so and I'm gonna adjust. Okay, that's pretty good, close enough. All right, I'm gonna use the scissor tool and actually make the parabola a little bit thicker so we can actually see it. So there's our parabola. So remember, we're emphasizing the solutions in this one. So your solutions here are going to be where it crosses the x-axis. So these 2 points here are really what we're looking for. So that coordinate here, we have 1, 0, and we have 6, 0. So that's really what we're looking for. So our solutions here, I can't count, that's not 6, that's 5. Yeah, I can't count, that's 5. It's fine, I only teach math. All right, so your solutions here, you're gonna have 1 equals x equals 1, 5. So these are your solutions. All right, so we went ahead and did solutions in Unit 8, but technically for Unit 8, all we really had to do were A through E. We just went ahead and threw on F because it was just, we're already doing everything else, we might as well just add it on. So really 9A is just a repeat of what we did in 8A. So there's really not much that's new. All right, so we're gonna do the second one as well. So same steps as before. So we're still gonna do our ABC values. So we have an A value of 1/2. We have a B value of 4 and a C value of 9. All right, so I need to find the axis of symmetry, which is the opposite of B over 2A. Oh my gosh, everything's a disaster. There we go. Opposite of B over 2A. So I want the opposite of my B value. So I have a +4. The opposite of that would be a -4. Then 2 times my A value, which is 1/2. All right, so in the numerator, I'm gonna leave that -4. Now in the denominator, we have 2 times 1/2. Half of 2 is 1. So when I simplify, we just have -4. So we are going to have an AOS value of -4. All right, so now I'm going to draw that vertical and dashed line at -4 I recommend making it a color that pops a little bit so you can actually see it. All right. So now I need to find the vertex. So I'm going to take the AOS value that I just found, and I want to plug it into my original equation up here to find out what the y value is. So I'm going to do f of -4. All right, so I'm going to have 1/2 -4 squared. And then I'm going to add 4 times -4. And then I want to add 9. All right, so I'm going to have 1/2 -4 squared gives you +16. Then 4 times -4 gives you -16. And we're going to add 9. All right, so this is going to be half of 16, which is 8. So 8 minus 16, which is -8, -8 plus 9, which gives you +1, which means your vertex value here is going to be -4, 1. So I'm going to go put a point on my line at -4, 1. All right, now we want to do the minimum and maximum. So looking at your a value here, we have an a value of a +1/2. It's positive, which means it's going to face up, which then in turn means we're going to have a minimum. All right, and then your domain, same as always, it's going to be all real numbers. I don't feel like drawing that again, so I'm just going to copy it from up there. Benefit of technology. All right, now for your range, remember it's contingent on your y value of the vertex. Now keep in mind, because we have a minimum, that means we want everything above that value. If we had a maximum, we'd want everything below that value. All right, so that range, we know it's going to be y greater than or equal to whatever the y value of the vertex is. So I'm going to come back up here to my vertex, and I want that y value. So 1. So everything greater than or equal to 1. All right, now I'm ready for the solutions. So same idea as always. If you're on a TI, go to y equals. And if you're on a Casio, go to your menu and go to table. So whichever one you're in, or whichever calculator you're using, plug in your function. So 1/2 x squared plus 4x plus 9. All right, so on a TI, you're going to press second graph to get to your table. And then on your Casio, you want to just press F6 to get to your table. And if you need to reset the table values, you can always press F5, reset the min and max values, and then go back to F6. All right, so I'm going to do my horizontal table. Or actually, hold on, pause here. So just some kind of logic for everyone that I want everyone to kind of be aware of. Think of what this graph is going to look like before we even do the solutions. We know we're going to have a minimum, and we know it's going to face up somehow on your graph. So think logically here. Does that ever mean that it's going to cross the x-axis if it faces up and it's above the x-axis? No, it cannot cross the x-axis. So automatically, what that means is we're going to have no solution here. So I don't even need to look at the table values to know, nope, no real solution. I almost fell for my own trick. No real solution. Okay. You still want to be able to graph it though, so go ahead and find the table values anyways. All right, so once again, start with your vertex. So -4, 1, which means you want to find the values after. So we're going to go to -3, -2, -1, and 0. All right, so at -3, we have 3 halves. At -2, we have 3. At -1, we have 11 halves. And at 0, we have 9. All right, so notice how we have fractional values here. If you have fractional values, you cannot graph those. You can approximately graph them, but you cannot exactly graph them. So I would just recommend leaving them off. So I'm only going to graph -2, 3 and 0, 9. All right, so -2, 3, which is up here. That's a highlighter. And 0, 9, which is right here. So we have the right side of the parabola, so I would recommend reflecting it over to the left side. And there's your parabola points. So now you just need to plot the actual parabola itself. It's actually pretty good. All right, so one thing to note about your parabolas here, this is more pertaining to anyone who's doing freehand or on paper. Whenever you're drawing your parabola, please make sure it curves at the end like this, because if your parabola has a critical point like this and it's more V-shaped, it is going to be wrong, okay? A V-shaped graph means something totally different than a parabola. It's an absolute value function, so you have to be careful to make sure it's curved at the end. All right, it's imperative that it's curved at the end if you're freehanding. All right, so that's really the review of 8A. So we're gonna kind of move on to the newer-ish kind of stuff. All right, so what if I actually give you the function and I give you these random points to check the validity? So when I say check the validity, that means you want to plug in that x value to the equation and you want to see if it's going to equal 0. That's how you know it's going to be a solution. All right, so you could either do this by hand or you could even use kind of some shortcuts on the calculator. It's really up to you on how you want to do these. So I'm actually going to do these by hand, and then you can use the calculator to kind of check it if you'd like. So what you're going to be doing is I give you 3 values. You're plugging in each value individually and seeing which one works, if any of them work. All right, so if you notice, these are actually the 2 equations that we just did. So x squared minus 6x plus 5, which is what we did up here. And we have the 1/2 x squared plus 4x plus 9. So we actually already did both of these, but then we're going to go ahead and check them algebraically and check the validity. So when I say check the validity, it's just a fancy way of saying check it algebraically, which is another fancy way of saying plug in the number, see if you get 0. All right. So your f of x value, when you plug it in, it has to equal 0. That's the important part. All right. So let's start with x equals 0. So I will do this one in purple. All right, so I have f of 0 equals 0 squared minus 6 times 0 plus 5. All right, so I'm going to have 0 squared, which is just 0, minus 6 times 0, which is 0, and then add 5, which gives you 5. So it doesn't equal 0, which means it's not a solution. All right, so I want to move on to the next one. So I'm going to plug in x equals 1. So I'm going to see if this one's going to work. All right, so I'm going to have 1 squared minus 6 times 1 plus 5. So 1 squared is going to give you 1 minus 6 plus 5, and that actually gives you 0. Why did I choose green for that one? All right. So that actually works, which means this is a solution. So x equals 1 is the solution. All right, and last but not least, I'm going to do x equals 3. All right, so you're going to have 3 squared minus 6 times 3 plus 5. So remember, we're plugging these into the original graph, the original function that's up top. So 3 squared, which is going to give you 9, minus 6 times 3, which gives you 18, and then plus 5. All right, so 9 minus 18 gives you -9. -9 plus 5 gives you -4. which is not equal to 0, so it doesn't work. All right, so that means this is not a solution. All right, so only one of these points ended up working. Just know up to 2 of them could work. So if you're getting a validity question like this and you get like 4 points that work, something happened. All right, so same idea over here. I'm gonna go through this one kind of quick. So I'll do this first one in orange. I'm gonna plug in -2. So f of -2. So 1/2 times -2 squared plus 4 times -2 plus 9. All right, so I'm going to have 1/2 -2 squared, which is +4, then -8 plus 9. So that's 2 minus 8, which is -6, -6 plus 9, which is 3, which does not work. So it's not a solution. All right, I'm going to move on to 0. So if I plug in 0 here, so we're going to have 1/2 0 squared plus 4 times 0 plus 9. So we're going to have 0 plus 0 plus 9, which gives you 9. And it doesn't equal 0, which means it doesn't work. So it's not a solution. All right. And last but not least, actually, no, let's not do green, just in case it does work. Let's not do red, do purple, the best color ever. Okay, so f of 2, so 1/2 of 2 squared plus 4 times 2 plus 9. So we're going to have 1/2 of 4 plus 8 plus 9. So 2 plus 8, or 1/2 of 4, which gives you 2. 2 plus 8 is 10, plus 9 is 19, which really does not work. So really, none of these work. None of them are solutions. So that's exactly how we would write it. Not a solution, not a solution, not a solution. Which is exactly what I'm going to do from over here. Not a solution, not a solution, not a solution. All right. So I will say these are more tedious and annoying than they are difficult, I would say. So if you wanted to do these in a calculator, it's the same idea. So on a TI, go to y equals, and then plug in your function, whatever function you're using, then second graph, and go to your table. And what you're looking for is you're looking for the y values to be 0. So in this case, none of the y values equal 0, which means there's nothing you can do. There's just no real solution on this one. So similarly on the Casio, go to table, execute, plug in whatever function you have, and then go to your table, which is F6, and you're going to look for the coordinates that have a y value of 0. So those corresponding values, those x values are your solution. So that's what you're looking for. So you could do these by hand, or you could do these on a calculator. It's really up to your preference. I would guarantee most of you would probably prefer the calculator. All right, so speaking of calculator and looking at the table, this is literally what we're doing next. So if I give you a table, what you're doing here is you're looking for where the y value is equal to 0. So the y value is equal to 0 here and here, which means those corresponding x values are your solutions. So your solution here is going to be 3 and 5, which that's all you're doing for these. All right. Now, because I'm the worst person ever and I'm not nice, you may actually have to fill in those table values. So same idea as before, you can actually go on your calculator and you can do them on here. Or if you want to, lost my train of thought. If you want to do them by hand, you can, which of course I know most of you are probably going to say absolutely not. So plug in x squared minus 2x minus 8. And then go to your table, either on your Casio or TI, doesn't matter. And you can literally just fill in those corresponding table values. So if you go to -4, let's see if I can count. So you're going to have 16 for that one. So that's going to be their first value. And then if you go down 2 more to -2, we have a y value of 0. And if you go down 2 more for 0, then we get a y value of -8. 2 more at +2, and you get a y value of -8. Then go down 2 more at 4, and you get a y value of 0. So you could literally just take the table from your calculator. It doesn't matter. If you want to sit here, plug and chug by hand, you can. It's up to you. All right, so just to kind of give you an idea, if you were to do these by hand, kind of plug and chug, it'd be f of -4 equals -4 squared minus 2 times -4 minus 8. So -4 squared is 16. -2 times -4 is +8, and then minus 8, which is going to give you 16. So it's just a repetitive nature of plugging it in and seeing what you get. So I'm not going to do it for all of them. So if you want to plug it in, you can. All right, so now looking at the graph, if we want to find the solutions, you are really just looking for those x-intercepts. So here for this first one, we have 2 roots, or 2 solutions, or 2 zeros, whichever you want to call it. So the coordinate of this first 0 here, we have 2, 0, and we have 6, 0. So remember, we're only looking for those corresponding x values. So which means our x values here are 2 and 6. That's what we're looking for here. All right, and now looking at this last problem here, notice how your equation does not even cross the x-axis, which means, sadly, we have no real solutions. Sad face. All right, so please remember, if you just write no solution, I am mean, and I would actually count off points for that. So like if the question was worth 4 points, I would probably take a point or 2 off, just because it's like saying your answer is not complete. It's like writing 2/4. Simplify it. Keep going. All right.